First three terms of a geometric series are k plus 4, k, and 2k minus 15, where k is a positive constant. I need to show that k squared minus 7k minus 60 is equal to 0. So a geometric series has a common ratio. So that means when I multiply the first term to get the second term, I'm going to do the same thing. I'm going to multiply the second term by the same number to get the third term. So we're constantly multiplying by the same number. I could find that number by doing the second number divided by the first number. So k divided by k plus 4. Or alternatively, I could also do the third number divided by the second number. That would also give me the ratio. And now I've got an equation. So basically the ratio of the first two terms is equal to the ratio of the next two terms. Now if I multiply both sides by k and multiply both sides by the k plus 4, expand the brackets, and then collect up the like terms then. Take the k squareds away from both sides. And that was the result that we needed to prove. So that's part A done. Part B. Hence, show that k is equal to 12. So carrying on from where we left off, I can solve this quadratic equation by factorising. So it's going to be k minus 12, k plus 5, because the 5 times the minus 12 will give me the minus 60. And the minus 12 plus the 5 will give me the minus 7. So therefore, either k is equal to 12 or k is equal to minus 5. But we were told in the question that k is a positive constant. So that allows me to eliminate the negative and say that k is going to be equal to 12. So now I know that k is 12, I can actually go back to the original sequence and work out and write down the first few numbers. So k plus 4, so 12 plus 4 is 16. The second number in the sequence is k, which is just obviously 12. And the third number, 2k minus 15, so 2 lots of 12 is 24, minus the 15 is 9. So the first term is 16, the second term is 12, the third term is 9, and so on. Part C, find the common ratio of this series. So what are we multiplying by each time? What is the common ratio? So 12 divided by 16, the second term divided by the first term is 3/4. And as a quick check, I could do the same thing, dividing the third number by the second number. 9 divided by 12, yet we do get 3/4. This is looking correct. We've got the same common ratio, which is 3/4. And then part D, we want to find the sum to infinity of this series. The sum to infinity does exist because our common ratio r is less than 1. So our sum to infinity will converge. The numbers are all getting smaller. The sum to infinity formula, you do get given it in the formula booklet, is a divided by 1 minus r, where a is the first term and r is the common ratio, So in this case, my first term is 16. My common ratio is 3/4. So 16 divided by 1 minus 3/4 is 16/1/4, or 64.